So my name is Roman Nurik. I'm a developer programs engineer for the Google Earth API and KML. So what that means is I help developers, third-party developers such as yourselves, use our geo-developer products such as the Earth API, KML, maps, etc. And I help you use it by kind of creating samples, demos, updating the reference once in a while, taking feature requests, bugs, things like that. So I kind of triage a lot of that, and I communicate that back to the software engineers that work in the product, and I'm kind of your liaison to the software engineers. So I like to think of myself in that way. One thing I wanted to say also before I start is there's a URL that you can go to that if you have any questions during the talk, you can write them down there, and at the very end of the talk, we'll go through and try to answer all those questions. All right, so, another thing, again, before I start, is I'm going to be talking a lot and doing a lot of demos. If you guys want to follow along on your own computers, then go ahead to this URL, tinyurl.com/earthapi-io2009-links. And for those of you on YouTube, hello, or wherever the camera is. I'll keep this link up for as long as possible, as long as tinyurl doesn't decide to delete it. So, happy first birthday, Earth API. Let's get a round of applause. So last year at Google I/O in 2008, Paul Rademacher, our tech lead, who's sitting in the front row, introduced the Google Earth API, and I'll talk a little bit about what the Earth API is. And we've had a lot of success. And a lot of people, a lot of third-party developers have started using this API. And as you can see, it's a 3D environment, right? And it's right in your browser, so it's great. And that is a birthday cake, so happy birthday. That's just my quick shout-out. What are we going to be talking about today? We're going to do a quick refresher. What is the Earth API? What is the Google Earth plugin? After that, we'll go into a new demo application that I want to show to you today called My Earth. And we're going to talk about some new utility libraries that I'm releasing today and how those are used by My Earth to make it so cool. Then we're going to talk about some animation effects and user interaction, how that, again, plays into My Earth and the new utility libraries. And then we'll talk about some really interesting other recent developments. And these are really, really important for Maps API developers. So if you're a Maps API developer that's been using the Maps API and also the Earth plugin by using the map type, the Earth map type, then you want to stick around for that definitely, because we have some good news for you. After that, we'll take Q&A from moderator and from the mics in front. So, quick refresher. I'm assuming that all of you kind of know what the Earth API is, but just in case, for the one or two people that don't know, let's go through what the Earth API and the Earth plugin are. So, better than talking about it is showing a real demo. So this is Google Chrome, and we now support Google Chrome, and we launched, Google Chrome wasn't around, but we now support Google Chrome. And this is the Google Earth plugin. Well, it's currently loading, but when it loads, it'll be, one second. The internet. Well, luckily I have another version here. So here's Google Earth, the full power of Google Earth, right? In your web browser. So there's no left panel that has like your My Places and such, and there's no layers. But there are the core fundamentals of Google Earth. That is the rendering system, all the imagery, all the vast imagery, the 3D buildings, and everything is available in your web browser, right? And then you can access that with JavaScript. You can make your own mashup on top of that. So that's the quick Hello Earth demo. So the Google Earth API is a JavaScript API that allows developers to create their own mashups that use Google Earth and do it all on the web. The Google Earth plugin is kind of the consumer, the end user side of this equation. And it's a browser plugin that takes the power of Google Earth and brings it into the web so that users can interact with your application as if they were in Google Earth, but looking at your content and whatever you want to show them. So here's a quick kind of system diagram of how this whole equation works, right? You have your own web application, your own client-side JavaScript on the left. That interacts with the Google Earth API in JavaScript. And then the Google Earth API takes care of dealing with all the kind of inner, plugin related stuff with the Google Earth plugin. So you never really directly deal with the plugin. You only really deal with the JavaScript API. So everything you do is JavaScript, and a little bit of HTML, a sprinkle of HTML. So I just want to talk about some of the things that we've accomplished over the past year that we've been around. We've launched Mac support back in December. So when we first, round of applause for the Mac users, yeah. We've launched Mac support. We originally only launched with Windows support, so now we support the Mac, Safari and Firefox. We also now support KML Tor playback. Now let me talk about that for a second. For those of you who don't know what that is, KML Tors were launched with Google Earth 5 back in February, and they allow KML content authors to create a beautiful movie-like experience right in Google Earth and now in the Google Earth plugin. So if you have some narration that you want to kind of put together that kind of explains your KML content, and you want to do it in a dynamic, interactive, kind of animated way, KML Tors are the way to go. We've also launched support for underwater terrain, aka ocean, as many people have called it. Mars mode, so you can, instead of loading Earth, you can load Mars. And enterprise server connectivity. So those of you who have worked with our enterprise sales folks, to get an enterprise server, you can now use the Google Earth plugin to connect to your enterprise server. And the demo gallery has grown to over 80 samples and demos. So you've got a lot of good resources out there, to get started. So that's the old. I wanted to spend as little time as possible on the old. Let's talk about the new. So previously, we've only really seen basic forms of interaction, basic visualizations, but there hasn't been really a killer 3D interactive environment where the user feels like they're in control and they can modify the planet, right? So this is what I want to present to you today is kind of a new paradigm, a new type of application for the Google Earth API. And that's going to be called My Earth. This is kind of manifested in this one demo called My Earth. And I'll do a quick demo of it, and then I'll explain what it is, how it works, et cetera, et cetera. So My Earth, when it loads. So My Earth is a 3D My Maps client that uses the Google Earth API. It's a mashup between the Google Earth API and the Google Maps Data API, which was launched only a few weeks ago. So I'm going to go ahead and log in. I'm not Peter. I'm going to sign out as Peter. So I'm going to go ahead and sign in. That's not it. One second. So it's going to ask me to log in once more. Yes, sign in. So I'm going to grant access to access my Google My Maps. And once the Earth loads, you'll see a list of My Maps. Let me open up maps.google.com on the side just so I can show you 2D versus 3D. So here's an example map. The example map I'm going to use right now. It's pretty much a polygon, a polyline, and 2 place marks. So here's My Earth. So I have the same thing. So I'm going to go ahead and click on Sandbox. And here's the same content, but in 3D. All right? So this is cool and all, right? So I can, click on stuff, and, it's a volcano, great. The fishes, that one doesn't have a description. Cordoning off the area, blah, blah, blah. So, it's very, very simple. It's just polygons and basic features in Earth. But the kicker is now allowing users to interact with that content. So if I go ahead and press this edit button, I'm going to see some cool stuff start appearing. First, I'm going to see this geometry toolbox at the top, just like My Maps has, which allows you to create place marks, right? And draw line strings. And if I zoom out a little bit, you can see that I can keep dragging this around however I want. I can even customize it. This is kind of overkill, for a demo, but anyway. Hello, and you can see it change. It should change in the left side there. Blah, right? Great. And then I can even create polygons. Much the same way. And if you'll notice, once I've created a polygon, I can then edit the polygon. And much like with my maps, I can actually, create new vertices right on the fly, right there and then. And I could delete vertices if I want, and et cetera, et cetera. You get the picture. So I'm going to go ahead and press save. Actually, I'm going to press done. And it's going to save all that. And I'm going to refresh Google Maps. And drum roll, please. There's all my new content. So 2D and 3D, married, right? Thank you. So there are a few things that are kind of new about this demo. And this talk, a large part of this talk is going to be talking about these new things and kind of how you can bring a part of this into your own applications. All right, so that was My Earth. What does it do? So you just saw it allows you to edit your My Maps data in a 3D environment. So this is great for when there's mountainous areas and Maps maybe doesn't quite cut it, but Earth is kind of a better experience for users to work in. So this is kind of what it does. Allows you to work in 3D, basic creation, reading, updating, and deletion of features, drag and drop place marks, edit polygon vertices, and screw them around with colors, fill colors, styles, etc., etc. How does it work? A lot of the back-end stuff is handled by the Google Maps Data API. But all the front-end stuff is powered by the Google Earth API and some new open-source utility libraries and that we're releasing today. And those open-source utility libraries allow you to do very easily animation and effects, creation of place marks, creation of all sorts of DOM objects very easily, very concisely. And it also lets you do feature editing, as you saw, with line, string, and polygon editing. It also works by creating those controls that you saw at the very top. Let me just go back a few slides. These controls up here, these are actually fake screen overlays that you can listen to event handlers on the window to kind of guess at interaction with them. And we'll talk about that a little more in a second. It also uses jQuery for a lot of the front-end HTML stuff, specifically the left-hand panel. So the open-source utility libraries. There's two libraries that we're releasing today. I'm going to talk mostly about the second one, but let me just talk a little bit about GeoJS, which is the first one. GeoJS allows you to work with 3D geometries in JavaScript. So you can work with points, lines, and polygons. You can do math on them, like get the distance between 2 points, calculate the initial bearing to get from point A to point B, calculate if a point is in a polygon or not, calculate the area of a polygon. You can also work with things like latitude, longitude bounds. A lot of this is actually repeated from the Maps API, but this is kind of open sourced. It's not the same code as the Maps API stuff, but it accomplishes much the same goals. So that's GeoJS in a split second. The Earth API utility library, or geEarth extensions, is kind of what you just saw. A lot of the editing and animation effect stuff, that's handled by that. So it allows you to create KML objects in a very JSONic way. So if you're a JavaScript developer and not really a KML developer, and you want to use the Earth API, this utility library may be for you. It also takes the pain out of common operations, such as walking the DOM, and I'll explain that in a second. Walking the DOM and getting features by ID, clearing features. A lot of developers have requested these things from the Earth API, and we haven't implemented them. But we now have a space where we can implement these common things in an open source way. It also has a very complex animation effects framework, and again, one-liner, draggable place marks, and editable line strings and polygons. And all this stuff is open source under Apache 2.0, so feel free to take it, screw around with it, do what you will. it's pretty much, as long as you abide by that license, it's your code. So how do you use geospatial extensions? I skipped all the kind of boilerplate Google Earth API stuff just so I can focus on utility library stuff. So all you do is you include a script tag that points to the geoearth extensions distribution JS file. Then inside of your success callback for create instance, after you get an instance of the GE plugin interface, all you need to do is just create a new instance of geoearth extensions, and you have all of that power and capability ready for you right there. So let's talk about one use case, creating a place mark. It's a very simple use case, but the old, kind of in the Earth API, it takes a lot of code, and let me explain why. The Earth API is modeled very much after KML. So in KML, to create a place mark, you have a place mark, and then inside of that, you have a style, and then an icon style, and then an icon with an href that points to some icon or some image file. And then you have a point with coordinates set to the latitude and longitude of the location of the place mark. You also have name and description and this and that. So if you look at the code, the Earth API, in the Earth API, you pretty much build a KML DOM. So you create that icon, you create that style, you get that icon style, and you set the icon. And this stuff is kind of not really KML related. But then you do stuff like set name, set description, set geometry. So it's modeled after KML. So if you know KML, then some of these things will make a lot of sense to you. So that's the Earth API way of doing it. The geoearth extensions way of doing it is much simpler and shorter. So to create a place mark, you call gex, and remember gex is that instance of geoearth extensions. You call gex.dom.addPointPlaceMark. You give it a point-like object, so you can give it a look at, a point. You can give it an array with a latitude and longitude. Pretty much anything that may resemble a point, you can throw at it. So you give it that. You give it a name, description, and a stock icon. You can even just use icon and give it a full URL. But this is much shorter, right? This is much more JSONic, or I don't even know if that's a word. It's much more like JSON as opposed to KML. So it really helps for people that don't know KML that well. It really helps to kind of use this and start off with a much simpler kind of piece of code. Let's talk about something else. So I was talking about walking the DOM, right? So walking the DOM it's important for various reasons. Let me give you kind of a use case. Let's say you're trying to play a tour in the Google Earth API. The way you do that is you first use something called fetch KML to load a KML file that has a tour inside of it. You then have to find the actual tour object within that loaded KML. So the way to do that is you would have to walk through each document, folder, maybe like look through all the features, looking for a tour, and then passing that to the tour player. So in order to kind of make that easier, I created a function called gex.dom.walk, which all it does is it takes a function. Where's the cursor? There it is. So it takes a function, and then it calls that function for every object in the DOM. And as soon as, and like for this example is a little simpler. It's just trying to find the feature with a given ID. As soon as this function gets called with the feature with the given ID, or in the tour case, as soon as the function gets called with a feature of the KML tour type, then you can kind of end the walk and say you're done. So it's gex.dom.walk is effectively a depth-first search into the KML DOM tree. So previously, a lot of things that required that type of algorithm were kind of painful, and this aims to make it a lot easier. So that's that. Let's talk about some of the cool stuff. Animation, effects, and user interaction, as you just saw in My Earth. So the first thing I want to talk about is draggable place marks. That was kind of the very simplest thing in the demo. Go ahead and close this, close that. All right, so here's the code for a draggable place mark. It's actually much simpler than this. I kind of overcomplicated this a little bit. It's really just that. But anyway, so if I go ahead and run this code, creates a place mark, you can drag it around, right? Even shows a target. That's a screen overlay over there. shows like the point at which that point will land. And then if I let go, it bounces it. So the dragging is kind of simple. The dragging is, it's just a bunch of mouse events. But the bounce is actually pretty complex. To actually use bounce is very simple. But the actual things that go behind the scenes to make bounce work are pretty interesting. And I'm going to talk about that. So actually, before I do that, here's the code for making something draggable. I'm just going to give it a drop callback. So when I'm done, when the drop is complete, I'm going to do an alert. The dragging style is, again, a JSON-like object. And again, this is going to be a theme throughout, that everything is JSON-like. It's a JSON-like object that kind of tells the style that the place mark should take on while it's being dragged. Then there's also a target screen overlay. So this screen overlay right here, you can describe in this way. And all of this stuff is kind of crafty. You don't really need that. The most important thing is just that icon. So as you can see, it's pretty simple. And this whole thing here is optional. So you could have completely omitted about 99% of this code and just said gex.edit.make draggable and give it a place mark, and you're done. So let's talk about bounce. Like I said, bounce is pretty interesting, so I want to talk about it in detail. Bounce works behind the animation and effects framework in geEarth extensions, which is grouped under the FX namespace, as you see at the top. So when you call bounce on a place mark, what that really is just a property animation on that place mark's point altitude. So I'm just saying, when I say bounce, pretty much this animate property will take the place mark, take its point, and just create kind of a property animation on its altitude with some extra code. And let's talk about animate property a little more, because that's pretty interesting. So this is what animate property looks like. So this is actually not bounce. This is something else. I want you guys to take a quick 10 seconds to look at this and try to figure out what it would do. And then I'll explain what it does. Actually, if anybody has any ideas, then you can raise your hand and come up to the speaker. No? All right. Okay. So what this does is it takes this place mark and it animates its point latitude. So it takes its latitude, increases it over the course of 250 milliseconds, increases its latitude by 0.05 degrees of latitude. And this easing out thing just means that it kind of slows down when it nears its destination. When the first animate property is complete, it calls a second animate property to do the reverse action, and it does the reverse easing too. So what this looks like, and unfortunately I don't have a demo of this, but you can just copy and paste it. What this looks like is it takes a point and it slingshots it kind of 0.05 degrees north in latitude, and then slingshots it back when it's done, and then throws up an alert saying done. Not a very useful thing to do in your real application, but just as an example, it kind of makes some sense. So that's animate property. Now, animate property is based on an even lower level construct called timed animation. And let me get into some details about that. So timed animation, you can forget about some of this first stuff. Timed animation takes a duration, like for example, in that sample it's 5,000 milliseconds, so 5 seconds. It takes a duration and a function, like a render function, and it calls that render function repeatedly as fast as possible over the course of that duration. So like for 5 seconds, that function, as you see there, is going to be called repeatedly. And it passes in the time at which the animation is currently at. So you'll get things like 0, 100 milliseconds, 200 milliseconds, 300 milliseconds. And the idea is that you do whatever animation you want. You update the scene in whichever way you want based on that time t. So this actually has the effect of creating a very smooth animation. So as soon as you can update the scene with the next frame of the animation, that function will be called. You'll make your changes, and it will be propagated to the view. So that's timed animation. And there's an even lower level construct called animation, which I'm not going to talk about. That's just an indefinite animation. So let's change gears a little bit and talk about the line string editing, the line string and polygon editing. To edit a line string or a polygon, that's all you do, one line of code. So gex, that edit line string, you give it either a line string or a linear ring. Linear ring in the case of polygons, outer boundaries. For those that know KML, a polygon is simply just kind of like an encapsulation of linear rings. So it works the same way for line strings and polygons. That's pretty simple. And here's what it looks like. So each coordinate is actually a draggable place mark. So if you remember, I was talking about draggable place marks and how it's really easy to make them draggable, right? How to make a place mark draggable with one line of code. So line string editing just uses place mark draggability, I guess. And if you look a little closer, you'll see that there's the main vertices and then that kind of ghost vertex, the vertex that users want to click on to create a new vertex. And if you use my maps, you'll know that this is kind of very much in the same spirit, and it works in much the same way. So again, I just want to emphasize that this is all handled by the utility library. You never have to deal with dealing with these midpoint place marks. You just say, make this line string editable, and everything just works. So that's a big part of the utility library. What I want to talk about now is a little different. It's about these controls. So custom controls have been probably the number one or number two feature request for the Earth API for a very long time. Unfortunately, it's kind of a hard problem to solve. The thing is, though, there are kind of workarounds or solutions, and the two solutions listed up here are they have different use cases. So I'll go through each of them. So screen overlays. In my Earth, the controls at the top are screen overlays. So what happens in the screen overlay scenario is if you want to make a button on top of Google Earth and on top of the plugin, you create a screen overlay in a certain area of the window, and then you add an event listener on the window for you just add an event listener on the window, and then when a mouse click event listener on the window, and then when you get that event, you just look for the X and Y's, and if they're within the range of that screen overlay, if they're in that rectangle, then you just do what you need. So you can do mouse over for like a hover state. You can do mouse out for the normal state, and click for the actual click handler. So that's pretty simple to do. I want to say one thing though, is that's not in the utility library yet, but it will be probably pretty soon. So you guys, if that's really important, then definitely vote it up in the feature requests. And one other thing I'll say about screen overlays is that since you can have transparent PNGs, you can actually make it look really nice, right? You can make it flow into your overall UI design very well. So if you see here, kind of the corners are rounded, and it blends in very well. So that's the screen overlay technique. It has its downfalls. For example, you can't really do dynamic text inside of it because screen overlays you can only use images, and that's why iframe shims can be a better technique. So iframe shims. For more complex UI, not just buttons, you want to use the iframe shim technique. What that is you create your HTML for your controls. So like, let's say you have a text box, so you just have like an input button or a div or something with an input inside of it. And what you do is you overlay that on top of the plugin. But the problem is, in the browser space, plugins naturally always appear on top of custom controls. So even if you set the CSS Z index of the control to something very, very high, it still won't show because of this native kind of browser thing that all browsers do. So the way around that is to use something called an iframe shim. So what you do is this. You have the plugin, right? This is the div. Imagine this is the div with the plugin. You create your control, and you set its Z index. You then create an iframe, an empty iframe that's right in between, that fits right in between Z index-wise. So let's say the Z index of this is 0, the z-index of your control can be like 2, for example, and then you set the z-index of this empty iframe to 1. And then you take that iframe and you set its coordinates to be the exact same coordinates as the custom control. The effect of this is to make the browser kind of be like, oh, this area should be its own window. And then the iframe doesn't actually show anything, so your HTML shows through it. It's a really messy browser quirk, the way it works. And hopefully in the future, this won't be necessary, and browsers will be kind of like a first-class HTML and browser element. But this is kind of the way it works now. So iframe shims are good for several things. They're good if you have really complex UI, like I said. But one problem with iframe shims is that they're, first of all, kind of cumbersome to work with in code. They also look cumbersome visually, and they kind of tend to flicker once in a while. So bottom line, after all of this, is if you just want to show some buttons, and you want to make them look good, and that's all you need, just buttons, use screen overlays. For anything more complex, like for example, text input or anything else, pretty much, you want to use iframe shims. And one last thing is that balloons, info windows, actually, in the plugin, in the Google Earth plugin, use this iframe shim technique. So that's how you can actually, well, let's do a quick. Let me just show you really quickly. And this doesn't have a description. This will be a good time to show how easy it is to change GEX code. So if I just go ahead and set this description to hey, and add a comma. So you'll see that if I select here, I'm selecting everything, right? So here, this is the iframe shim right here. You can't see it because it blends in with the balloon background pretty well. But that's actually an iframe shim. So there's an iframe under there. If you inspect the code, you'll see an iframe. So that's kind of the same thing that you could do in your code to accomplish this effect. And there's also a demo in the demo gallery showing how to use this technique if you all want to try that. All right, so that's pretty much how My Earth works. And then there's a lot of back-end stuff with the Maps Data API, the JS client library for that. And I'd gladly take questions on that if you'd like. But that's pretty much it. There's nothing else that's really seriously new besides those kind of new concepts. So feel free to look at the code for My Earth. It's open sourced. It's not in the demo gallery yet, but I'll probably put it up there pretty soon. So yeah, enjoy. So thanks. All right, so other recent developments, and here's where Maps API folks will want to pay very close attention. Back in May 2008, we released the Google Earth API, as you all know, right? We also released concurrently a Maps API compatibility layer called G-Satellite 3D Map. Now what that means is that in your existing Maps API application, you'd be able to, in one line of code, I mean that's our kind of common theme throughout every developer product we have. With one line of code, you can add the Earth, the Google Earth as a map type for your map. So you'd be able to just say map.add map type G-Satellite 3D map, and when users click on Earth, a lot of things would be synchronized. So like it would switch from maps to Earth, and you'd see your markers and polygons transferred automatically. However, and this is a big caveat, the integration wasn't as good as it could have been. There was kind of the transition between 2D and 3D wasn't as seamless as it could have been. Polygons, ground overlays, a whole bunch of other features simply weren't transferred over. They were pretty much forgotten. And a lot of developers have struggled to kind of get that working recently. And there have been a lot of workarounds, and it's just there's no great solution. However, today, I want to announce that we finally have a solution, and everything works just a whole ton better. So the left guy is the old kind of version of G-Satellite 3D Map. The guy on the right is the new version. He's beefier. And if you look at the bottom, I have some demos for you. And the first one is the beefy demo. Actually, first I'll show you a video, because the video is pretty stunning. And then I'll show you the live version. have to press play, of course. Oh, okay. So this is maps, right? Press Earth, instant Earth. Did you guys even notice? Well, let me play that again. 2D, blah, 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 blah. 2D, panning around. Done. Earth. So you can't even tell, right? And you can also see that ground overlays and polygons are transferred over as well. And you can do the same thing, same thing you would normally do in Earth. And it's kind of laggy there because of that Golden Gate Bridge. And when you click back to satellite, let me play that again. When you click back to satellite, it takes the 3D viewport and kind of seamlessly animates to exactly what it would be in 2D, so that users can barely tell they're in 2D and 3D. So let's see this live. Wow, right, exactly. And by the way, shout out to the engineers that worked on this. You guys are brilliant. So let's go ahead and. Yes, it's the same. It's almost the same tiles. So let's look at this actual demo in progress. I got a little beefy man over there. So let me just point out what's on the screen. There is a polyline, this orange thing. There's a marker. Then there's a marker with a custom, and that's not working for some reason. It's supposed to be a marker with a custom event handler, but something's broken. Anyway, so you have a ground overlay. I couldn't find a better image to use, sorry. And a polygon. So screen overlay, polyline, marker, and pretty much everything you can think of. The kitchen sink is in this demo. So if we click on Earth, it still does take a little bit to load the plugin, but when it does load, everything is transferred over. And if I go ahead and press satellite, and I can click back to Earth, and satellite, and Earth. I'm telling you, I honestly sometimes have a hard time figuring out where I am, like 2D or 3D. I try to tilt in maps, and it just doesn't work. So that's one demo. One other thing I want to point out is that for KML content authors, you've had to use kind of really crazy hacks to get maps and Earth working together. So that's, again, no longer the case. With this new version, GeoXML, which is the kind of the Maps API way of looking at KML files, is now fully transferred over between 2D and 3D. And not only are polygons and polylines transferred, but let's say you have a 3D model in your KML and you load it using GeoXML. Although maps won't display it, when you switch to Earth, that model will appear. So everything is just fully synchronized. So if a user decides to see the full rich extent of 3D of your KML, they can just switch to the Earth tab, and it's done. So let's look at a quick demo, the GeoXML demo. By the way, these links are all available on your computers now, and I'll show you that tiny URL again in a second. So very basic KML. And it's going to load the plugin really quickly, hopefully quicker in the next couple months. We'll see. I need to do one of those Lars song and dances right now. Hello? Let's try refreshing the page. So I'm going to go ahead and load and press Earth. Okay, so everything gets transferred over, right? Same old good stuff. Barely tell the difference. If we load, well, that's the basic KML. Let's load a more complex KML in satellite. This is actually still loading. It's pretty complex. So Earth. So you see that screen overlay, right? So satellite. And actually, I guess Maps didn't show that screen overlay. I wonder why. We'll have to ping the Maps team about that. But it works, again. And this is GeoXML. So the code for this is actually incredibly simple. That's pretty much it. GeoXML, map.addOverlay GeoXML. So your URL, your KML URL would go right here, and you'd add this GeoXML object, and you add that Earth map type. And when users switch to Earth, they see Earth 3D KML. And just one last one just for the road. This one's pretty complex, right? Maps has some, the Maps API has some kind of complexity limitations when viewing KML files in them. So, but Earth doesn't. So this is kind of an optimal solution for everyone. So satellite if you want, or Earth. And again, I can't get over that effect, sorry. Okay, so that's that. So now that's available today. All you need to do is use the version 2.160 of the Maps API, or version 2.x. Maybe in a few weeks or so, eventually, all this new code, this new version of G-Satellite 3D Map, will be available in the Maps API, the regular Maps API. So, yeah. Next thing I want to talk about really quickly before we finish off is Embeddable KML. And this, again, we're done with the utility library. Now we're just talking about other cool stuff. So let's say you don't like working with JavaScript, but you do like KML, but you do have a website. So originally, you would have to use the Earth API, figure out what JavaScript calls to make to load your KML into the browser. Now and this is actually a few months ago we released this. You can, instead of working with JavaScript, you can just use a Google gadget that takes a KML URL and spits out some HTML code. You copy that HTML code into your page, and you're done. So let's just show a quick demo. So this is a demo of world oil consumption. This is a KML of world oil consumption. I believe it's a thematic map. It's still loading. There it is. Right. So it's a thematic map, and this is again Google Earth in the browser. But there's zero JavaScript on this page. There's no JavaScript. There's no script tag. Actually, there is one script tag, but this was copy and pasted from the gadget wizard. So let me show you what this looks like. If I go ahead and go to the wizard. All you need to do on this page, well, this is going to load the plugin again. All you need to do on this page is enter a KML URL or a MyMaps URL. Let's see. I need a KML URL. I'm not very good with. Hold on. What better than Google to look for KML? Here, that's fine. I don't even know what that is. Hopefully it's not something bad. Yeah, I will not be held liable. I'm just kidding. Yeah, let me get something that I know, just in case. Here, trunk, examples. Yeah, hold on, I'll get it in here. Static, red.kml here. I know this one because I made it. The plugin is still loading. One second. Okay, so let's. All I need to do is paste the KML in here, paste the URL. There it is. And now it's going to preview. This is what the KML looks like. All right. And I'm going to press get the code, and that's it. I just copy this into my page, and I'm done. I don't need to worry about any JavaScript or anything. This is actually, again, linked to from that set of links. For those on YouTube, if God forbid that the thing goes down, it's tr.im/embedkml, and this will get you to this page. So Embeddable KML is cool, but as I mentioned before, what about touring? What about Google Earth tours? Those movie-like experiences, those movie-like interactive experiences that you can make in Google Earth 5. Well, you can now play that in the plugin pretty simply, and again, without any JavaScript. So you just go to a different wizard. This is the touring wizard. Give it a KML that has a tour in it. It'll automatically find your tour inside that KML, so it can pretty much be anywhere. And again, press get the code, and just copy that, and you're set. So here's what that looks like. And I chose the Jimmy Buffett Hawaii tour, and a lot of the engineers here are going to be sick of hearing this because we do a lot of testing specifically on this one. But actually, you can't hear the voice, but it's fine. So again, all interactive, and I can pan around while everything's. So I want to look at that house. Well, that's weird. Yeah. So, and again, 0 lines of JavaScript. So that's embeddable KML in a nutshell. So for people that don't like JavaScript or don't know JavaScript and just want to have KML on their page, this is the tool for you. All right. So that's pretty much the talk. Before we take questions, I want to kind of do a quick shout out to developer qualification. We have a new program called the Qualified Developer Program. And this is for Maps API developers, not yet for Earth API developers. This is for Maps API developers. Just go ahead and visit this URL if you feel like you're qualified, if you want kind of some Google cred for your skills in the Maps API. Go ahead to this URL and get yourself qualified. So that's the talk, and let's take questions. And that's the URL where you find everything. Thank you. So we'll take questions either at the microphone, and let me go ahead and open up the I/O moderator page. Any questions?
The Google Earth extensions, the walk functions.
Right.
Does it actually walk through the XML or KML?
Yeah, it does.
Structures.
Say it again. What was the last?
Would there be a performance penalty if it has to walk through to find something?
Right. Okay. So that's a good point, and I'm glad you brought that up. So when you do a fetch KML, the only thing that gets put into JavaScript is the root level item. As soon as you do a KML DOM walk, each of those items is getting a JavaScript kind of equivalent object. So there is a pretty large performance penalty if your KML is very large, and if if the actual thing you're looking for is at the very end. Right, exactly. So there are cases where that can incur a pretty large performance penalty, and for that reason, a lot of pretty simple things like getting a feature by ID.
Or maybe a support to XPath. I don't know if there's.
Right. So like something like XPath. I mean, those things can be supported in this utility library, but there are other kind of ways of doing that. For example, a lot of people have requested this to be natively part of the Earth API, and that's an ongoing feature request. So it would be a lot faster, of course, if get feature by ID or something like that was in the Earth API, and that's probably something that I'll work with the software engineers to try to include. But there are no guarantees, but that's a pretty honest feature request.
So by ID, it has.
Say it again?
By ID, it just has, so it's a lot faster.
Right, exactly. Yep.
The My Earth plugin stuff looks pretty cool.
Thanks.
Is there some plans to bring that to Firefox on Linux?
Firefox on Linux. So support for the Google Earth plugin support on Linux. I can't really comment to that effect. Our product manager is sitting right there, so he'll be able to take Linux-related questions. And I absolutely knew I was going to get that question, but.
So I'm the one who has to answer questions when I have to not really give you an answer. So we don't have anything to announce right now. Obviously, we're very interested in cross-platform support, but right now we just have PC and Mac. So, but we do support Firefox on those platforms.
Yeah. So Firefox and Mac is supported, but Linux again, it's still questions up in the air. Any other questions? Yep.
When I last looked at Google Sites, it didn't take iframes. Do your iframe shims go into Google Sites? And does this go into Google Sites, or are there difficulties? Right. So usually you can just, since it's a Google gadget and Sites supports gadgets, arbitrary gadgets. Yes. There usually is no problem. Only recently there's been a problem with API keys. I think there was a problem with maps, that I came across. Right. So last I checked, that problem was fixed. If it's not fixed, then that's definitely something that we should look into further. But last I checked, it was fixed. So what you would do, let me just clarify for everybody. There's a gadget URL, right? So if you go to tr.im/embeddkml, there's a gadget URL. It's actually just an XML file. If you take that XML file and give it to Sites, I think add gadget by URL, give that URL to Sites, it should just work. Again, the only reason it wouldn't work, to my knowledge, is if there's still that API key problem. Right. Thanks.
When you're on the polygon on the Google Earth, you're setting your vertices. Can you get the latitude and longitude out of the vertices, or are they XY coordinates based on the map location?
So they're all latitudes and longitudes. I'm assuming you're referring to like the editable line strings and polygons, right?
Yeah.
So you give it a place mark that has a line string. The utility library will notify you as soon as there's any changes to the vertices. Right now, it doesn't tell you which vertex was modified, so you won't, you'll have to kind of figure it out, I guess. But that's a pretty simple thing to implement. So if that were a feature request, that could be pretty.
So
simple.
given 12 vertices, I'd have the latitude and longitude
right,
at each
so,
point.
So if that feature was implemented and it gave you the vertex index, you just look in your coordinates, get that coordinate at that index, and get the latitude and longitude. It would be pretty simple.
Thanks.
Yeah. Any other questions? No. Okay. Thanks everybody for coming. Oh, yep.
Can we use the same libraries for the Google Earth Enterprise?
Google Earth Enterprise. You should be able to. It's just JavaScript. It's pure JavaScript, so you should be able to. Yep. Without a problem.
Maps API 3 supports.
Oh, Maps API v3 support for G satellite 3D map. It doesn't support that yet, but again, I can't comment to whether or not it will or any roadmap for that. But it doesn't support it as of now.
That extensions library, does it come packaged, or does it reference a lot of external URLs?
It comes completely standalone, and it's completely minified. So the full library. By the way, the extensions library includes the GeoJS library and the Earth API extensions library. That library altogether is 40K. It has no external dependencies.
I meant for all the images on the place.
Oh, images? So it doesn't. So the only images it works with are stock images. Images like the blue paddle, the red paddle, things like that. The images for the geometry toolbox that you saw on My Earth, those actually aren't part of the utility library. So those were just custom for My Earth. But the utility library doesn't have any image dependencies. Make sense?
Yeah, kind of.
Do you know of any techniques to capture thumbnails and/or video of Google Earth?
That's been a very often requested feature, specifically thumbnails and screenshots for the use case of printing, right? That's, in general, it's kind of difficult. Just the simple problem of how does a client-side plugin create a stream that the browser can access, right? One idea would be to use data URLs or something. It's a technical problem that's pretty difficult to solve, and we are thinking about it, but we haven't made any progress on that. One thing you can do, I don't know if this is legal in terms of imagery capture, but one thing people have been able to do was to take the plugin, embed it in a web browser control inside of a desktop application, and then have the desktop application take a screenshot of that. And I'm not sure if that violates any terms of service. And Peter would probably know, but that's the technical way of doing it.
I'm always the bad guy who's come up here. So yeah, in general, within the terms, you're not allowed to pull content out of the context of Google Earth. So you can't take a screenshot and bring that into another application or something, because that's a violation of the terms. But we're also looking at ways, are there additional things we can put to the API to, we have, for example, a static maps API that allows you to embed images from satellite imagery. So that's one way that you can bring that in. So.
All right, so it looks like there's no more questions. Thanks, everybody, for coming. And I just want to throw up that URL again for anybody that wants to... Wait. There we go. So this URL will have all the links to all the demos that I've done today, and as well as the links to the utility libraries that we've just released. Thanks, everybody, for coming.